morning, and welcome to Thinking Logically. In today's episode, we're going to be giving our full attention to Flat Earth physics professor D. Marble and his explanation of why the Earth can't be round.
One of the comments that I always get in these flat earth videos that I'll upload, typically the ones I'll do about the movements of the celestial bodies or gravity, one of the responses I always get from these globe believers, the more triggered ones, is you don't understand physics.
Alright, I just want to stop there for a second and point out the psychological aspect of what he's doing so far. He started out with the background photo of a person visibly upset, shouting at their computer, and then he calls them triggered. He does this to put the viewer in the mindset that the people disagreeing with him are irrational and not capable of having an intelligent debate. He then goes on to condescend to those triggered individuals by calling them physics experts.
And my response is always pretty much the same. I'm like, oh look, another physics expert. Well here, how about this, genius? Go ahead and explain the physics of liquids or water in large quantities. Now, do they ever do it? No. For some reason or another, globe believers like to tiptoe around that particular aspect of physics.
That's a very vague question for someone to answer in the comments of a video. Physics is the study of matter, energy, and the interaction between them. So asking someone to tell you everything about water and its interaction with everything else in the universe is probably a question I would ignore too.
So let's do a quick check on understanding, a real simple rudimentary exercise, and then we're going to look at physics real quick. How about that? Now, what do you see here? A globe. B, a bowling ball. C, a spherical balloon.
Even though I've seen balloons that look like that, I'm going to assume that he means a globe. I should warn you though, I am ridiculously good at multiple guess tests.
Boom. A globe. Moving on. Now, what is the most prevalent surface color on this globe? A, white. B, green. Or C, blue.
Since we're talking about the physics of water today, I'm going to go with C, blue.
Blue. Very good. What does the blue on the globe represent? A, land masses. B, water. C, lava.
B, water. This is a really easy test. I hope we get a flat earth degree at the end of this.
B, water. You would be correct if you guessed B. Under what state of matter is water classified? A, a solid. B, gas. Or C, a liquid.
D, all of the above.
And if you chose C, you are correct.
I think I'm starting to understand why people question his
knowledge.
Now, let's take a look at the conclusion here. Most of the Earth's surface is covered by liquid. That's what we just established by answering those questions. Still with me? Good. Now, let's take a quick look at a short video outlining the physics of liquid.
Liquids seek their own level. Let us perform an activity to show that liquids seek their own level. Take a series of interconnected tubes of different shapes as shown here. Pour colored liquid into one of the tubes. Observe that the liquid stands at the same horizontal level in each tube, even though the area of cross-section of each tube is different. We know that the pressure at the top of each tube is equal to the atmospheric pressure. Similarly, the pressure at the bottom of each tube will also be equal. Hence, liquids seek their own level.
This is just one physical aspect of how water interacts with containers and has more to do with the surrounding air pressure than it does to do with the liquid in the container. If you were to apply different air pressures to all of the openings, they would all be at different levels. She even explained that in the video.
Okay, so to go along with that, here's an example. Here's a cross-section side profile of the Panama Canal. Now, what you can see is on the far right side, it shows the Pacific Ocean at sea level, which you can see is pretty much flat on the surface. And then what happens is the boats move across Panama through a series of locks, rising and lowering the level of the water, moving across the landmass, and then coming out to the other side on the Atlantic Ocean, which is also at sea level. Now this side profile here shows that, in correlation to what we just saw as the physics of water, that the surface of water is always flat. That water, liquids, seek to find their own level.
First, I hate to be the one to break it to you, but that's a drawing. It looks exactly how the artist who drew it thinks a cross-section of the Panama Canal would look if you could photograph it. Second, the term sea level is a bit of a misnomer. There are two types of sea levels. There's a global sea level, which is an average of all the local sea levels. As a matter of fact, the Atlantic and Pacific Oceans have different sea levels.
Now, you in your own personal experience have never seen water do anything on the surface other than represent a level surface, as if a perfect mirror. Now, if the surface of water were bulging, such an effect wouldn't be possible. This whole mirror thing that we have going on right here, that's not possible if the surface is curving.
Are you saying reflections come from flatness?
But then this is where people would make excuses saying that this particular body of water is too small and that there's not enough space to see the curvature. So let's take into consideration what you're seeing here. This is the world's biggest mirror. It's the salt flats in Uyuni, Bolivia. This place is 100 miles across and about 80 miles wide. And after it rains, there's about an inch or two of water and it becomes a perfect mirror, as you can see here. That doesn't happen on a globe. That's entirely too much missing curvature. So you know the physics of water. Water seeks to find its level, and that's what the surface of level water looks like, right there. Perfect mirror. Accumulates and gives off that reflection, indicating that there is no curvature on the surface.
An object's flatness has nothing to do with its ability to reflect light or create a mirror effect. That comes from its smoothness. Because water molecules are small and the water is calm, it creates a mirror. You also have to be at the proper angle with respect to the light source. But if you think that the entirety of the physics of water is that it seeks its own level, I can see how that might escape you.
This is one of my originals from a while back, and this is just to get you thinking about this stuff, the simplicity of where we are. Whether it's water in a glass, whether it's in a pond, a puddle, in a lake, or on the ocean, the surface is always flat and level. You need to take into consideration the fact that bodies of water only appear to curve in pictures that you will never be able to take for yourself. And that's the pictures of the entire globe. Chances are you're never going to go to space and be able to snap that picture. Neither am I. But what we know in our reality is that the surface of water is always level. So, I'll admit it that both of these models have their own flaws. But you gotta ask yourself, which one of these matches your experience in reality? What's closer to what you know? Water clinging to the outside exterior of a ball, or water finding its level? That's all I got for this one. As always, be good to each other, take care of yourself, and stay flat. I'll see you next time. Thank you.
This has been a logical critique of leading flat earth physicist D. Marble's explanation of the physics of water. Thanks for watching, and we'll see you again next week.